अच्छा, वही पहले तो बेसिक बेसिक स्टार्ट कर लेते हैं, फिर we'll shift to yield and तो ये बाकी सारे हैं काम। अच्छा, ये क्वेश्चन करते हैं। वी हैव ही सेइंग 1 mole, one of the compounds produced is a form of calcium silicate। अच्छा, क्या वो कह रहे हैं, calculate the mass of calcium hydroxide ये calculate the mass of calcium hydroxide formed from 912 grams of this thing। So this thing is how many grams? 912 grams। तो किस तरह सॉल्व करना है कि you find the moles of one thing and you'll be able to find the moles of everything। So mass is given, so moles can be found out by dividing it by the MR, which is calcium जो है, that's 40 times 3, silicon is what, it's silicon 28, and oxygen is 16 times 5। Zarar calculator, Rania, what do you get? How many moles do you get? Zarar, Ibad, आवाज आ रही है?
जी सर।
Ibad, ये moles तो calculate करो। How many moles do we get?
सर एक सेकंड कैलकुलेट कर जाने दें।
अच्छा ठीक है रानिया, 4 moles, ठीक है। So we're getting 4 moles। और रेशो क्या है? उसने कहा he's asking for the mass of calcium hydroxide। You find the moles of one thing, you'll be able to find the moles of the other thing as well। तो वो क्या होगा? It's 2:3। So 4 moles divided by its 1 moles, 4 divided by 2 times 3, right? So यहाँ पे moles क्या होंगे? That's going to be 4 divided by 2 times 3, which will give you how many moles? 6 moles, I think। तो बस ठीक है। So you find the moles of one thing, you'll be able to find the moles of the other stuff, right? Or all you have to do is you have to find mass, which will be moles multiplied by MR। So you have the moles, which is 6 moles. Multiply it by the MR of this. Calcium is 40. O is 16 times 2, and H is 1, and that's times 2 as well। ठीक है, remember it's 3 का कुछ नहीं करना। You already did that। We did 2:3, so which is why we got 6। अच्छा, what's the answer now? Dania, what's the answer? Ibad, Darar, what's the answer? अच्छा, किसी ने कैलकुलेट किया ये? 444, ठीक है। So we're getting 444 grams. Yeah, that's the answer. As anyways, let's do a few more questions similar to this. Let's try and do this one. There's a reaction, and it says that there's an equation, and there's a octane burns in air. which I think this is what he means by octane. It burns in air or carry a petrol-powered motor car travels at a constant speed of 80 kilometers per hour. For every kilometer traveled, 108 grams of carbon dioxide are formed. And when the motor car travels 100 kilometers, so calculate. I said, so what is basically happening is for 1 kilometer, for every kilometer, okay, for a single kilometer traveled, 108 grams of carbon dioxide is produced, right? So 1 kilometer, it produces how much? 108 grams of carbon dioxide. And the motor car travels 100 kilometers. So that means so total carbon dioxide. What is the mass of carbon dioxide emitted, right? So for 100 kilometers, it's going to be 100 times more, right? So let's say my screen is gone. 1 second. Just a second. So coming back to the question. So the question states that 1 kilometer the car is traveling, it's producing how much? 108 grams of carbon dioxide. So in total, the car is traveling 100 kilometers. So it's going to be 100 times that, right? So what is 100 times this? It's 108. It's going to be 108 grams times 100, right? And that's going to be okay. That's going to be 10,800 grams, right? Two zeros added. So it's going to be 10,800 grams. So that's the mass of carbon dioxide that's going to be produced. Now, he's saying the mass of petrol that's going to be burned by the car. So the only information right now you have in the reaction is for carbon dioxide. So you know that this is the mass of carbon dioxide. If you know the mass, what can happen is you can calculate the moles. So you got the mass of carbon dioxide. We can convert that into moles, which is mass divided by molar mass, 10,800 grams divided by the MR of carbon dioxide. Carbon dioxide is going to be what? It's going to be carbon is 12. Oxygen is 16, and that's times 2. So that's 32 plus 12, that's 44. So I'm going to calculate the moles of carbon dioxide. So ye karo, what do we get? It's 10,800 divided by what? Divided by 44. And I'm getting 245.45 moles. Okay, that's the that's the moles of carbon dioxide that are going to be produced. Now, 245.45 moles of carbon dioxide. And he's asking you to figure out the mass of petrol. So if you know the moles of one thing, you'll be able to figure out the moles of the other thing, right? So ratio क्या है? 16 ratio 2. So how do I calculate the moles of C8H18? It's going to be the moles of this thing divided by its own ratio multiplied by the ratio of the other stuff, right? So the moles would be 245.45 divided by its own ratio, which is 16, and times 2, right? So basically, I have to divide this by 16 and then times 2. So what would that be? It's 245.45. And so these moles are coming out to be, they're coming out to be 30.68 moles. They're coming out to be 30.68 moles. So is this clear that you had the mass of carbon dioxide, which meant that you could calculate the moles of carbon dioxide. And once you have that, you can use ratios and you can figure out the moles of C8H18, which is 30.68 moles. Now, once you have moles, now you can calculate the mass of petrol, right? So mass would be moles multiplied by the molar mass. याद रखो क्या formula था? It was moles is equal to mass divided by mr. So mass would be the moles multiplied by the mr, which is 30.68. And what's the mr? It's C8H18, which is, what would that be? It's going to be 12 into 8. And H is 1, so there are 18 of them, so that's going to be 18. So try and calculate this. What's 12 times 8? That's, I think, that's 96. Plus, I need to add 18 to it. That's 114, and then I have to times 30.68. So it's coming out to be what? 3497.52 grams. ठीक है? Is this clear? ये clear? Yeah, is this clear? Rania Zarar, is this clear to everyone?
जी जी
अच्छा, so that's the next one. Calculate the mass of nitric acid oxide formed when 100 grams of nitrogen reacts completely with oxygen. So again, you're given the mass of this thing, and that's what, 100 grams. So you can calculate the moles of this thing, which is 100 divided by the mr of this thing. There are 2 nitrogen, so that's 28. So क्या आता है? What's 100 divided by 28? That's coming out to be 3.57 moles. And once you know that, then it's 1:1, so the other one would be 3.57 moles as well. That's double, so that's 3.57. And you're going to multiply it by 2, and you're going to get 7.14 moles. Okay, so once you find the moles of one thing, you'll be able to figure out the moles of all the rest by using ratios. And उसने कहा कि you find the mass of nitric oxide. So you just need to find the mass, which is moles multiplied by the molar mass, and that's going to be 7.14 multiplied by the molar mass, which is NO. That's 14 plus 16. That's 30, right? The molar mass nitrogen is 14 and oxygen is 16. So that's a 7.14, and I have to multiply it by 30. So I'm getting 214.28 grams. Okay, that's my answer. I said next. I said next is that I'm going to do the last two things which are required. We did limiting excess in the last class. यहाँ पे. So now in the last class, we did limiting excess questions. So there's another thing which we're going to do in this class, which is yield. Or basically percentage yield. I said, now the moles question is pretty much the same. It's you find the moles of one thing, you'll be able to find the moles of all the things in the reaction. I said, what is yield? Yield is that, for example, there is the theoretical output. You have a theoretical value. So let's say and theoretical value is the one that's the calculated value. That's the value that you get on your calculator. You didn't actually do the experiment. You didn't actually perform the reaction. So it's an estimation. It's something that you're trying to calculate. It's something that you just got on your calculator. So it's not the actual value. So you have the theoretical value, which let's assume it's somebody says that 150 grams of carbon dioxide is produced, should be produced. So all the values that you get on your calculator, all the values that we have so far gotten when we are solving all those questions, they're not they're not the real value. They're just calculated values which have been done on the calculator. And then there's an actual value which is also known as the experimental value. And this value tends to be very different from the one that you got on your calculator. So the actual value, let's say you thought that you were going to get 150 grams of carbon dioxide, but when you did the experiment, something went wrong. Many things could go wrong. And for just as an example, maybe you just got 40 grams of carbon dioxide produced in reality. So this is the real value. And normally there's a gap between the two. So you're estimating that 150 grams is going to be produced, but in reality, 40 grams is what you're getting. There are a number of reasons. A lot of times your actual value mostly is less than the theoretical value. And there are lots of reasons for that. Maybe you're using impure substance. There's a lot of impurity, which is why you're not getting the right output. So maybe you're using a lot of impure substances. There might be a lot of wastage while you're doing the experiment. A lot of stuff got wasted, fell out of the container, or is not used up completely. So maybe not all the reactants react. And there's a thing about chemistry, which is that a lot of times reactions don't always go to completion. I mean, for example, you try to burn a match. It is very rare that the entire match completely burns. It's very hard to burn the complete match. So reactions don't mostly go to completion. So what happens is you can estimate that the amount of carbon dioxide or the amount of heat that's going to be produced when you burn a match. But the problem is that the match would probably not get burned completely in the reaction, which is why the actual value would come out to be very, very different. So yield is there's a simple formula for yield, which is the actual value obtained or the experimental value divided by the theoretical value, which you should have obtained if everything went 100% right, times 100. Okay, that's what your yield is. Okay, just then you've got crop yield. Like you estimate that you're gonna get a certain amount of crop, but in reality, a lot of things go wrong and you don't get always what you expected. So it's the actual value over the theoretical value. Now, all the math that you're doing, that's all about the theoretical value. The actual value, you can never get the actual value unless you actually perform the experiment. So I'm going to calculate yield in this case. Okay, we expected 150 grams of carbon dioxide to be produced, but in reality, 40 grams is getting produced times 100. So if you do the math, this would come out to be Okay, this is 40 and divide by 150 and times 100. And that's coming out to be 26.67%, which is really low. So generally what happens is you want your yield to be very close to 100%, but it's never going to happen. I mean, close to 100% means that what it means is that whatever you're estimating that that's going to be your output, in reality, that actually comes out to be your output. Okay? So if you're thinking theoretically on your calculator that 150 grams should be obtained, when you go and do the experiment, you get 150 grams, that's 100% yield. So you want your value to be really close to 100%. But there's a lot of things going wrong in the real world, which is why reactions, they tend not to go to completion. This way, what needs to be done is that we can do a question. For example, there is so for example, there's a reaction. You've got C6H12O6, and that is turning into ethanol plus CO2. And if I balance it, that's four oxygens, two oxygens, six. Yeah, it's balanced. So the question states that 100 grams of glucose produces, let's say, 15 grams of ethanol, right? And they're asking us to calculate the yield. Because for most people, I'm pretty sure that you know what glucose is. Glucose is this thing. Now, the first thing I'm going to do is I'm going to calculate the theoretical yield, which is if I have 100 grams of glucose, what is the amount of ethanol that should be produced? In reality, not in reality, on my calculator, what is the amount of ethanol should I expect to be produced? So remember moles, I'm going to calculate the moles of glucose. So that's C6H12O6. So moles is what? Mass divided by a molar mass. It's 100 grams divided by the molar mass of glucose. Is Sadeko, if you add all of this up, it's carbon is 12 times 6 plus hydrogen is 1 times 12 plus oxygen is 6 and the MR of sorry, there's 6 oxygens, the MR of oxygen is 16. You add up all of that, it's going to give you 180, right? So basically what you have is you've got 100 and you have to divide that by the MR, which is 80. So 100 divided by 180 and that gives me 0.55 moles. So I'm getting 0.55 moles of glucose. Now, theoretically speaking, one glucose produces two ethanol, right? So basically, it's going to be double. The moles are going to be double, right? So what is the double of 0.55? That's if I double this, it's 1.11 moles. So the moles of you find the moles of one thing, you'll be able to find the moles of the other thing. So the moles of ethanol are coming out to be 1.11. I can now calculate the theoretical mass. So what is mass? Mass is moles multiplied by the MR. You're going to write the formula the other way around. We have the moles, it's 1.11. We need to find the MR. What is the MR of C2H5? Oh, so it's 12 times 2, that's C2. H5, and there's another 8, so that's 6 plus 16. So 24 plus 16, that's 42 plus, no, 24 plus 16 it's 46. So 1.11 times The MR is 46. So now if I do that, it's 1.11 times 46. It's coming out to be 51.06 grams. So this is all theoretical. This is all done on my notebook. I didn't actually do the experiment, but what I've done is I've figured out the theoretical value that in an ideal world, this is the amount that you should expect. Okay, so if you had 100 grams of glucose, you will have 100 divided by 180, you'll have 0.55 moles, and the other moles are double, so that's 1.11 moles, and you were able to. So in an ideal world, you should be getting 51.06 grams. I said, the question says, what does the question says? The question gives me the actual value. He didn't state it, but it's the actual value. The question states that he's getting only 15 grams. So what is the yield? The yield is going to be the actual over theoretical. So he's getting, in reality, he's getting 15 grams. What he was expecting was 51.06 grams and times 100. So 15 divided by what? 51.06 and times 100, and we get 29.3%. So that means during this reaction, my yield comes out to be 29.37%, right? So that is my yield in this question. So I'm going to do. Here, is this clear? Rania, clear? Why did you get this? So next thing is, here, is this clear? Here, can you hear me?
Yes, sir, it is.
We're going to do another yield question, which is so here's a yield question where you have the question says that 10 grams of calcium carbonate reacts with excess nitric acid. We'll make it phosphoric acid. And it then says that 2 grams of carbon dioxide are obtained. Okay, let's make this 30 grams. So 2 grams of carbon dioxide are obtained. And he's asking you to calculate the yield. So first thing is you need the reaction, which is calcium carbonate reacting with phosphoric acid. You need to know what the ratios are. So it's calcium phosphate plus carbon dioxide plus water, right? And you need a balance equation. So if you balance it, it's going to be 3 calcium carbonate, 2 phosphoric acid molecules, 3 carbon dioxide, 3 H2Os, right? Now, the first thing is you're going to calculate how much calcium carbonate is reacting. That's 30 grams, right? So you can calculate the moles. 30 grams Divide that by the MR of calcium carbonate, which is calcium is 40, carbon is 12, and you have oxygen, which is 16 times 3. Now, when you do that, what you're going to get is 30 divided by 40 plus 12 is 52 plus 16 times 3, that's 48, and that's going to give you 100. This value comes out to be 0.3 moles. So that means I have 0.3 moles of calcium carbonate, and using ratios, I can figure out the moles of all the reactants and all the products in the reaction. So 0.3 moles divided by 3 times 2, that's going to give me 0.2 moles. So similarly, 0.3 moles divided by 3 times 1 would give me 0.1 moles. This is the same ratio, 3 ratio. I mean, the other one is the same ratio, carbon dioxide and so carbon dioxide and calcium carbonate have exactly the same ratio. So it's 3 ratio 3. So that's going to be 0.3 moles. So anyway, since the question was about carbon dioxide, I'm going to stick to carbon dioxide moles. I'm going to find the theoretical mass. अभी मैं recording share कर दूंगा end में. I'm going to find the theoretical mass of carbon dioxide. In an ideal world, what should we get on my calculator? So it's 0.3 moles, and I'm going to multiply it with the amount of carbon dioxide, which is 44. I'm just going to straight away tell you that it's 44. So it's going to be 0.3 times 44, and that's going to give me 13.2 grams. Now, this value over here is my theoretical value. It's the value that I'm getting, that I'm supposed to get. This is the expected value that I'm getting on my calculator. Now, he says that when he does the experiment, he's only getting 2 grams. So that means that's probably the actual value that he's getting. When he did the reaction, he did not get 13.2 grams. He's only getting 2 grams. So you can now calculate yield, which is the actual value, which is 2 grams, the theoretical value, or the one that you're expecting on your calculator, that's 13.2 times 100. So that's a very bad yield. I mean, that's a lot less than 13.2. So it's 2 divided by 13.2, and that's just 15.1%. Okay, so that is very poor yield. Clear? Is this clear? Yes, this clear? Nabila, is this question clear? Nabila, we're doing yield. So let's try and find some yield question in past papers. T. I'm just going to try and quickly find some yield questions. Yeah, this one is about percentage yield here. So we're going to try and solve this one. Now, the question states that he's given us two values. He says that there's 8.88 grams of calcium hydroxide and there is 7,200 cm cube of chlorine gas, and they're mixed together. Now, the first thing is he's given us information. It's a limiting and excess question as well. The first thing is 8.88 grams and there's 7,200 cm cube of chlorine, right? So he's asking for the moles. Moles is what? Mass divided by molar mass. So it's 8.88 grams, which is the mass divided by the molar mass of calcium hydroxide, which is calcium is 40. And oxygen is 16, and there are two of them, and there are two H's as well, so that's two. So कितना होता है? 32 and 74, I think. So it's 8.88 divided by 74, right? So I'm getting 0.12 moles of calcium hydroxide. Now, in the same question, he's asking for the moles of chlorine gas as well. For gases, moles is what? It's the volume of gas. You can remember the four formulas. Volume of gas divided by 24 dm cube. So the volume is 7.2 dm cube. Remember, you don't use the volume in cm cube. So I took 7200, I divided that by 1000 and divide that by 24 dm cube. Okay, so how many moles is this? This is 7.2 and you're going to divide that by 24. I'm getting 0.3 moles. So I'm getting 0.3 moles. So he's saying what is the maximum number of moles of calcium chlorate that can be made when these two react, right? That's the other part. So it's a limiting and excess question. If you look at the question carefully, in normal questions, you know the moles of one thing, and using ratios, you're able to figure out the moles of the rest, right? So in this case, one of them is in excess, and it's pretty easy to spot. It's easy to spot because it's the same ratio. It's 6:6, which means they should react in the same amount. So that means 6 would react with 6. So that means they should be in equal amounts, right? So if 0.12 reacts, then 0.12 of Cl2 would also react. That means 0.3 is in excess. Only 0.12 moles would react because 0.12, sorry. Because you don't need 0.3. Uh, the equation is suggesting that they are reacting in exactly the same ratio. So 0.12 will react with 0.12. And remember when you were doing excess and limiting reactant, I told you that the excess moles are not used. So you're not going to use 0.3 in your calculation. So all your ratios, the next ratios are going to be done using 0.12. So it is 6:1. So that means 0.12 divided by 6 times 1. And you'll get the mass of calcium, the moles of calcium chloride. So what is 0.12 divided by 6? That's going to be 0.02 moles. So it's going to be 0.02 moles. So he's asking what is the maximum number of moles of calcium chlorate that can be made. So that's coming out to be 0.02 moles. I'm repeating this once more. We got 0.12 moles, we got 0.3 moles, but when we found the ratio, it was the same ratio, right? So we figured out that 0.12 will only react with 0.12. It doesn't need 0.3. 0.3 is a lot more than 0.12. So which is why that was in excess. It was not going to completely react, which is why I removed that from my calculation. You never use the excess moles because they're not completely reacting. And then using ratios, simple ratios, it's 6:1. So 6:1 means 0.12 will react with 6 times less. So that's 0.02. And then he says, what is the maximum mass of calcium chloride? Now we figured out 0.02 moles. We have the moles, we can multiply it by the MR of calcium chloride. So it's 0.02 moles multiplied by what is the MR of calcium chloride? It's this thing. So they didn't give us the MR, so it's calcium is 40. Plus there are 2 Cl, so that's 71. Plus there are 6 oxygens in ClO3, so that's 16 times 6. So we can find the mass. Okay, so I'm trying to find the mass now. So what are we getting? It's 40 plus 71 plus 16 times 6. That's 207 and then times 0.02. So I'm getting 4.14 grams. This is what I'm getting. So I'm supposed to get 4.14 grams. Now the last part is a yield. Yield is normally the very last part of a question. Now he's saying that the actual mass of calcium chloride that he got in the experiment was 3.62. Now this was the one that we are getting on our calculator. So what is the percentage yield? Yield is simply the actual mass that he is getting, that's 3.63. What he's supposed to get, the one that my calculator is giving, that's 4.14 times 100. So you're supposed to get 4.14, but you're actually getting 3.63. So 3.63, and you're going to divide that by 4.14, and you're going to times 100. And that's coming out to be 87.68%. ठीक है? Yeah, is this clear, Rania? Is this clear? Nabila, clear? Yeah, but we're going to stop here, ठीक है? And we'll continue tomorrow now.
Sir, I need to ask you something.
ठीक है. Mike, can you call me on my WhatsApp?
Yes, sir, it's about my first time today in today's class, and that's what I need to discuss.
Yeah. Can you directly call on WhatsApp then?
Okay, sir, no problem.
Okay. Take care.